All right. Hello, everyone. Welcome to the session. This is session 2
Hello.
of machine learning on cloud and AutoML. Right? We decided that we will do AutoML, explainable AI, and AutoML. Okay. Just give me a quick minute. All right. So let us proceed further. Yesterday, we started off with AutoML, and we also understood that even without writing a single line of code, we can accomplish machine learning algorithm. Right? And as part of that, we discussed that hyperparameters can be optimized, neural architecture search can be automatically performed, feature engineering can also be automatically performed. There is also something called as meta learning. Meta learning is all about learning from the results of your model. So I'll not get deep into that. At a later point of time, we will look into what is meta learning, etc. The first question which arises is automated machine learning, AutoML. Does this mean end of the role of data science or end of the role of data scientists rather? Answer is no, friends. Automated ML can only do so much. First of all, you need to understand what is the business problem, right? The business problem has to be documented. Automated ML cannot help you with solving business problems or identifying business problems automatically. It cannot do that. So we as humans should identify the business problem. So human intervention is still needed. Number 2, data collection. To a great extent, what data has to be collected? What features do we need for our model building? For all these things, we need human intelligence. We need human brain, right, for this data collection as well. And for feature engineering, if you want to apply your domain knowledge, then also human intelligence is needed. For example, just as an example, suppose you have 2 columns and you're trying to predict vehicle breakdown. The output variable is, will a vehicle break down or not? Okay, so will a vehicle break down or not? Say this is the output variable that you're trying to predict. And you have certain inputs. Inputs are how old is a vehicle, how many kilometers did the vehicle travel, right? Say these are all the various inputs. And also you have couple other inputs. One is latitude, another is longitude or longitude, however you want to pronounce that. Usually people will feel that number of kilometers driven or how old the vehicle is and number of kilometers driven are very important, but latitude and longitude really does not make sense in predicting whether a vehicle will break down or not. But then if you have your domain knowledge, experience of working in automobile industry, then you would say that I am going to use latitude and longitude, and given these two, I would try to come up with a new variable called as location. Based on location, you can figure out whether it is a hilly terrain or whether it is a desert. If it's a desert, maybe vehicle might break down because of overheat, so on and so forth. Okay. So this is not end of data science, right? AutoML or automated machine learning is not the end of data scientists. Automated machine learning can only automate a few tasks where a lot of human effort is invested. Okay. However, understanding the business problem, collecting the right data, performing right feature engineering based on the domain knowledge, all these things are very important. And here you have automated ML. Right? Automated ML can only solve toy problems, is what people think. One myth that we have demystified is you should not think that AutoML would end the role called data scientist. No, it will not do that. And the second assumption is that automated ML can only solve toy problems. Not really. Identifying the right neural network architecture or identifying and looking at all the various hyperparameters is not a small task by any means. Right? It's not a trivial task. So automated ML is also solving complicated problems. There are a lot of open source platforms and tools such as Microsoft NNI. We have Auto Scikit-learn, sklearn, AutoVeca, AutoKeras. We have Teapot, Ludwig, AutoGluon, feature tools, so on and so forth. Out of all these things, I'm certainly going to walk you guys through and explain you all about Teapot. Okay, we are going to do hands-on end-to-end using Teapot. Okay, and we shall also use at a high level something called as feature tools. Right, we shall look at both of these. These are from open source platforms and tools point of view. And we will not use deep learning. See, friends, when it comes to machine learning algorithms, you have two things, or two branches rather. One is traditional, wherein you have a bunch of traditional machine learning algorithms, such as decision tree, random forest, linear regression, so on and so forth. And on another side, you have deep learning algorithms. Okay, you have deep learning algorithms. When it comes to deep learning algorithms, we are going to look at something called as AutoKeras. After we explore these, we will also look at how do we deploy the models in production. That is yet another thing that we shall look at. A lot of people know how to build models, but they really don't know what should we do after we build the model. Where should I go and deploy the model? Okay, we shall also look at the deployment aspect so that the entire pipeline end-to-end is understood. Next, we also have a lot of commercial tools and platforms, meaning you need to pay. Okay, as part of this, we have Google Cloud AutoML, you have Data Robot, you have SageMaker Autopilot, Azure Automated ML, obviously AI, H2O driverless AI, and bunch of things. Okay, we have bunch of additional platforms. However, we are not going to look at all of those. Okay, we are going to look at only these three: Google AutoML, SageMaker Autopilot, and Azure Automated ML or Azure ML Studio. Okay, we will explore all these and we will theoretically understand the concepts and we shall also practically solve it, right? But until we get to this stage, you have to just wait a bit, because once we understand how the pipelines are automatically built, then when we look at automated solutions on cloud, you will be able to easily understand, okay, and what's happening behind the scenes. Okay, next. So friends, when it comes to entire data pipeline, machine learning pipeline or data pipeline, whatever you want to call it, you can also call it as machine learning pipeline. These are the various phases that we have. You'll have data ingestion. Data ingestion means getting the data from various sources. Maybe you have your HR department, which stores the data in SQL database, your HR department. Maybe you have your sales department, which uses some kind of a CRM. Maybe it uses customer relationship management database from Zoho. Okay, and maybe you have some other department which stores the data in a simple Excel file, Microsoft Excel. And you have data in 3 different data sources. Data ingestion means getting the data from all these different sources and then you also try to get only the appropriate variables from these databases, and you ingest it. That's called as data ingestion. Once you get the data from different sources, you need not always have the data which can be readily used to build models on top of that. A lot of data cleansing is needed. A lot of data preparation is needed. A lot of data pre-processing is needed. We do all of that, and then we take the prepared data and then supply it to our model. When we build a model, you need to choose between 2 things, or rather, two broad things. One is, are you building a model in the field where there is a lot of regulatory norms? If you have a lot of regulatory bodies, regulatory norms to be abided, like banking, if you reject a loan, you need to explain why you rejected the loan. If the customer comes back to you and says, hey, why did you reject my loan? Can you explain me? If you fail to explain, in certain countries, you can be sued. Your bank can be sued. To avoid that, you will use explainable models. So you end up using regression models or decision tree models, etc. That's one thing that you need to look at before choosing a model. Second thing is, what is important? Performance or accuracy? Sometimes people might say, hey, there is a big basket, which is e-commerce website where you can purchase vegetables. Say you're searching for tomato. Along with that, big basket will recommend a few other vegetables. Now, there, more than accuracy, speed is important. You want those recommendations to happen immediately. All those you want all those to appear on the screen, recommendations immediately. Right? In that case, you have to use a model which will give the results faster, as opposed to building some kind of ensemble models. Okay, we also have something called as ensemble models, which will give you very good accuracy, but then it'll be slower. So it's not always about accuracy, friends. It's also about the business requirement, right? So those are the aspects that you need to consider. Then you train your model, and then you evaluate and figure out which is the best model. And once you figure out what is the best model, you deploy the model in production. But while you get into this modeling phase, choosing the model, training the model, evaluating the model, a lot of experiments can be performed. And that is the area where people usually spend huge amount of time. You take all your prepared data or features, supply it to your modeling phase. In the modeling phase, you have model selection, model training, and model evaluation. You have three different things. You select the right model, you train the model, and then you evaluate the model. While you evaluate the model, if it is deep learning, then you also look at neural network, right? You look at all the various neural networks and you try to search for the best. Then you also perform hyperparameter tuning. You try to change the different options with a neural network algorithm and keep experimenting with that. And until you get the right model. Once you get the right model, you deploy it. So those steps which are listed in the dotted window are the steps which are very time consuming. These are very time consuming tasks which can be automated. And these includes automated feature engineering, automated model selection and hyperparameter tuning. Then we also have automated neural network architecture selection. Your AutoML can automate these steps. Okay, next. As I've told you, I'll spend quite a bit on the theory, because once you understand the theory, when we do practicals, it'll be walk in the park for you. All right. So once again, you have this data pipeline wherein you collect the data, you clean the data as part of your data preparation. As part of feature engineering, you perform feature extraction, feature selection, and feature construction. Then as part of model generation, you select the right model. Then you perform hyperparameter optimization. When you perform hyperparameter optimization, you might want to use randomized search or grid search or Bayesian optimization or reinforcement learning or evolutionary algorithms or hyperband. There are a bunch of algorithms which exist. And finally, you evaluate the model. As part of model evaluation, we have early stopping, low fidelity, surrogate, parameter sharing, bunch of things. I mean, we'll not get into finer nuances or details of each point here, because that would defeat the entire purpose of the session otherwise. Yeah. So automated hyperparameter tuning is all about learning the different hyperparameters for the model, right? And sometimes this gets bundled with the learning of the model itself, and it forms or becomes part of the larger neural architecture search. And this is called as full model selection or cache, combined algorithm selection and hyperparameter optimization. And NAS is also known as, this neural architecture search, NAS, is also called as automated deep learning, because ultimately, if it is neural networks, then it is deep learning only, right? So from that point of view. Next, this is how we have, a bunch of techniques: automated model choosing and hyperparameter optimization. When it comes to hyperparameter optimization, you have a technique called as grid search. What happens in grid search? Friends, when it comes to neural networks, neural network algorithm, you have a lot of hyperparameters, such as you have something called as learning rate. We have something called as dropout. And you have various other things like number of hidden layers, number of neurons in the hidden layers, activation functions, batch normalization. I mean, you have a bunch of things. Out of that, we are only taking two for our understanding. Suppose you have two options of learning rate, which is zero point 0.1 and 0.01. You want to experiment. What will happen if I choose learning rate as 0.1? What will happen if I choose the learning rate as 0.01? And you also have dropout. You are interested to understand what if I do, or what if I select dropout value as 0.2, or what if I select the value as 0.5. Okay, so here your model, when you do grid search, it will try out all the combinations. When I say it will try out all the combinations, what I exactly mean is it will take 0.1 learning rate and 0.2 dropout. Learning rate 0.1, dropout 0.2. And it will build one model. Then it will choose learning rate as 0.01, dropout as 0.2. And with that setting, you build the second model. Then you choose learning rate as 0.1, dropout as 0.5. And then you build a third model. Then you choose learning rate as 0.01 and dropout as 0.5. And then you build a fourth model. In this way, you try out multiple models with all the combinations. Here, since you have learning rate with two options and dropout with two options, you'll experiment 4 different varieties. And then you will choose one model which is the best. Now, rather than do it manually, all these experiments, you can make use of a technique called as grid search, which will automatically try out all the combinations of hyperparameters and the options of the hyperparameters. And then it will give you the best result. But sometimes, since this is called as exhaustive search, meaning it will search or it would experiment with all the combinations. If you have more levels in your hyperparameters, if you have here we have 2, instead of 2 you can also have 20. Here also you have 2, instead of 2 you can have 10, 20, whatever. So then the number of models that have to be built will just explode. It'll take huge amount of time. Hence, people came up with something called as random search. This is very, very similar to grid search, with the exception that it will not try out all the combinations. Randomly, it might select 1, 2 combinations. Randomly. If you have 4, out of that, randomly 2 or 3, it will select. So it will be faster. Because it is faster, it is also called as cheap. Because it will complete the work faster. So it is cheaper for you guys. Okay, but then it won't be as good as grid search, because grid search does all the permutations, combinations, and gives you the best result, right? But random search will only randomly choose a few. Then we also have Bayesian search. Okay, this is yet another technique based on probability to decide what is the best model. So it will build randomly certain combinations. It will build models using some combination. Say it uses learning rate and dropout, and randomly it builds a model. And then its goal will be to keep reducing the loss or keep increasing the accuracy of the model. So it will keep tweaking the hyperparameter such that the accuracy is maximized. Then we also have something called as hyperband. Hyperband is a very, very new technique now in the world, and a lot of people are trying to use hyperband. Okay, next. This NAS we already discussed enough, so I'll just skip this part. NAS is neural architecture search, which will help you figure out whether given your data, fully connected network or your multi-layered perceptron, should that be used, or convolution neural network or recurrent neural network, etc. And then it will figure out the best model. So that's it. So I'll skip this part. And I would recommend highly that you guys read this Nastnet, which is learning transferable architecture from sizable image recognition. Just, you just go through it, read it, and Nastnet generates models for you. Okay, it will actually generate different models for you. And these models often outperform state-of-the-art human design models. If you're manually doing the models, if you're manually building the models, then be rest assured that Nastnet generated models will be much superior, much better in terms of accuracy and performance. Next, we also have something called as Amiban. Since nowadays what is happening is people are just increasing the number of parameters that the model learns. And we have Amiban, which is one of the amazing revolutions in the space of image classification. Okay, and it's giving amazing results. And that too with far fewer resources. When you have far fewer resources, you can try out Amiban. It works wonderfully well. Okay, next thing is the number of parameters are exploding because of the processing power, because of the compute which is available. When I say compute, I'm talking about RAM, I'm talking about processor, etc. These terms are important, friends. It is very important for you to remember the terms. So if you have more RAM and more processors, you can have more weights. You can have more parameters. More the number of parameters, better will be the accuracy. And if you look at the highest accuracy models, those models with more number of parameters are winning the race. Next. So automated feature engineering. We will look at feature tools for that. Automated model and hyperparameter search. For that, we are going to look at Teapot. Okay. And automated deep learning NAS, neural architecture search. For this, we should look at AutoKeras. Okay, and then rest of the things are for your quick glance. Okay, of course, we will not have time to look at everything. Okay, one more thing. One more term rather that you need to understand. Once you have your data set for analysis, you have candidate feature generation. That means you generate a lot of features from the data. Then you rank your features. And then you select what are the important features for you. This part is actually automated big time. This is called as feature selection. Okay, you figure out what are the various features that you have. You rank them in the importance, in the order of importance, and then you select the right features. Next. Every model that we're going to build has internal parameters and external parameters. Internal parameters, or your model parameters as people call, are internal to the model. That means if you look at a neural network architecture, for example, you'll have weights, weight. All these are weights. All these are weights. Okay. And finally, you get an output. And combination of all these weights will give rise to a weight matrix. Weight matrix is something which is internal parameter. And then you have something called as external parameters, which are outside of the model, like learning rate, number of hidden layers, batch size, so on and so forth. All these are external parameters. And your hyperparameter optimization will deal with your external parameters. And it will try various combinations of learning rate, number of hidden layers, batch size, so on and so forth, and give you the best results. Okay. So, yeah, these are the bunch of tools that we have, which are all related to AutoML. And we already know what we are going to explore, right? We are going to explore Teapot, AutoKeras from this entire plethora of models that we have. And then we are also going to look at feature tools. Okay, yeah. After this, I think we'll get into Teapot. So quickly, 2 more slides before we jump into that. AutoML or Auto AI is a process of automating the entire pipeline. Entire data pipeline can be automated. And another goal of AutoML or Auto AI is to democratize machine learning or deep learning to non-data scientists and non-AI experts. What does that mean? Data scientists will anyways use machine learning models. AI experts will obviously use machine learning models. We are aware of that. But can I help a layperson? Maybe, for example, can I help a doctor, physician, use machine learning without they having to learn far too many things? Can I actually ensure that within one day, people who are non-technical folks start using machine learning algorithms? Can I do that? Yes, absolutely. When we look into hands-on of AutoML, you SageMaker Autopilot, you'll simply be blown away. We'll get there eventually in the 4th module or fifth module. We'll get there. Okay. All right. So you'll have a lot of questions to answer before you get started on any project. A lot of problems to be solved. So you'll have a lot of questions to answer. You first go and acquire the data, go collect the data that is needed for your analysis. Then you perform data exploration. Right? You perform exploratory data analysis. Then you prepare the data, pre-process the data, clean the data, remove the outliers, deal with the missing values, etc. Then we perform feature engineering. Once you are done with this, the model construction phase begins, wherein you select the right model, you train the model, and you tune, perform hyperparameter tuning. Once this is done, you go ahead and deploy your model in production. Once you deploy your model in production, people can use the live data or the real-time data or the actual data. Okay, and they can supply this to your deployed model. And once you supply to the deployed model, you get the predictions, which will give you the answers, obviously. Okay, fine. Next thing. So in automatic data preparation, we have 2 main aspects: data cleansing, data synthesis. In data synthesis means if you have less data, you try to generate more data. say you have images, say you have radiology images. Let me show you how a radiology image looks like. Just quick understanding. Radiology. Here we go. Okay, this is how the radiology images appear like. This is all. These are breast images, radiology images to determine breast cancer. Okay, if you want to determine breast cancer, those are the kind of images that you need to deal with. Usually, when you want access to radiology images, you'll have only limited images. You will not have huge number of images. Only a small set of images is what you're going to have. But if you have only a small set of data, I mean, if you have say 3,000 images, you cannot build deep learning on such small data set. It won't give you good results, even if you try to. What do I do then? You synthesize, you augment, you try to get more data from the existing data. How? So say these are all the images. What you can do is you can rotate the images. If the image is like this, say you have a human face like this, then rotate it. How? You can rotate the way you want it. Maybe you rotate it like this by say 20 degrees or clockwise. You can also rotate 20 degrees anti-clockwise. You can flip the image. You can do many things. By doing that, you'll have more images which will be generated. Even if you try to just rotate the image by 20 degrees, for these 3,000, you'll have another 3,000 images. Okay. And then we also have feature engineering, in which we have feature selection. You select the most important features. You construct, you come up with new features. And also we have feature extraction. Usually when you use automated feature engineering to extract the features, then you can use traditional models also, no doubt about that. But usually people use deep learning models, which has this automatic feature engineering capability. Then you have automatic model generation. Automatically different algorithms are selected, different hyperparameters are chosen, and grid search or random search or Bayesian, any of these is applied. Then you have NAS, neural architecture search, ENAS, genetic programming, evolutionary algorithms, bunch of these. Then we have hyperparameter tuning, wherein you tune the hyperparameters. Right. Okay. Once again, here is a snapshot of different AutoML, frameworks which exist, and what technique do they use internally is also something which is given, like Bayesian optimization, or what technique it exactly uses. Now, here we go, Teapot. So there are 4 levels of automation which people usually resort to, right? One is basic automation, wherein you take, suppose you're manually recording the electricity details. For example, you will have an electricity meter, right? And do you remember the good old days when someone from the electricity department would come? They will look at the readings on your meter, on how many units you have used, and then they will charge you accordingly. Manually, they used to do that. That process has been automated to a great extent now. It is being automated. So this is some basic automation. Entire process also can be automated. Okay, for example, say a particular patient, okay, goes to a hospital and takes an appointment. Okay, manually they usually do that, right? You either call or manually you do it. Then patient will go talk with the doctor, physician, and then doctor is going to record the entire details on what disease you have, what is the medication on a piece of paper. That's called a subscription or prescription, however you want to call it. Not subscription, sorry, my bad, prescription. So doctor will give you a prescription. Then you go give it in the pharmacy and then collect medicines. All this is one process, right from the patient getting into the hospital until the patient comes out of the hospital. Can you automate this entire process? Absolutely. Absolutely. You can instead have a mobile application wherein you can book the appointment. You need not do it manually, call them and check. Based on the available slot, you go to the hospital. When you talk with doctor can use some kind of a Bluetooth device. And the entire conversation between you and the physician or between the patient and the doctor can be digitally recorded. So you're automating the entire process. Then this information, since it is digitally recorded in a database, can automatically go to the pharmacy. And the moment you walk to the pharmacy store, your medicines are ready. You just go collect your medicines and walk it. We also have integrated automation. Meaning, say you as a patient are going to the hospital by your car. Okay, you're traveling via car. You can also register your car number in the mobile application. When you do that, the moment you are at the hospital gate, it will automatically open and you can go into the hospital parking area. And also your GPS or geofencing will guide you to the nearest available parking lot so that you go and park your vehicle. What are you doing? This is a completely different thing. Helping you integrate your vehicle details in the mobile app. You making use of computer vision to automatically detect your number plate and open the barricade here. And then guiding you to the nearest parking lot. All this is, all this would, mean that you need a lot of other applications. You can integrate all of that. And you have AI automation. AI automation, simply put, think about driverless cars. Driverless cars would actually help you perform the automation automatically. And then we have Teapot, which we will talk about this. Teapot uses a lot of machine learning algorithms and then figures out on what is the best machine learning algorithm. Say it uses an algorithm called as XGBoost. XGBoost is one of the algorithms, okay? In this algorithm called as XGBoost, which is a machine learning algorithm, you have a lot of hyperparameters such as booster, verbosity, validate parameters, number of threads, disable default evaluation metric, number of p-buffer, number of features. So if you really look at it, 1, 2, 3, 4, 5, 6, 7, there are only 7 hyperparameters. You might say, what is the big deal in automating these? I can remember these 7 and I can solve it, is what you might feel. But then, in XGBoost parameter, in this booster hyperparameter, if you select the option as, in all these, you once again have different options that you can select. Okay. In this booster, if you select an option called GB tree, then what happens is bunch of other hyperparameters come into picture. All these eta value, gamma value, maximum depth, minimum child width, max delta step, bunch of options will come into play. And you need to select these options manually. First of all, you need to understand what each of those mean, right? You need to first of all understand what do we mean by gamma? What do we mean by sampling method? What do we mean by lambda, alpha? And what are the various options of each hyperparameter? You need to be, first of all, aware of all these things in order to manually select an experiment. However, AutoML can come to your rescue. You need not worry about any of these hyperparameters. You just use Teapot, job done. I'll show you practically on how that works. Okay. Teapot actually stands for tree-based pipeline optimization tool. Okay, and this Teapot actually automates these components which are in the gray color. Okay. So you take the raw data, you perform data cleansing. Data cleansing is something which is not performed by Teapot, but then feature selection, feature processing, feature construction, selecting the right model, performing hyperparameter optimization. All of these are automated by Teapot, which is tree-based pipeline optimization tool. And then finally, you get the validated model as output. Okay, so let's jump in and understand how these components can be automated. So that means model selection, model training, hyperparameter tuning. If it is neural network, slight change we need to do. I'll explain you where we need to do that. But that is also something that can be performed. Okay. And finally, you deploy a model. Deployment has to happen manually, friends. For Teapot, you can deploy the model manually. You can either decide on whether the deployment should support offline, asynchronous, or batch processing, which we discussed in the previous module, or online, synchronous, real-time deployment. So you can decide. These are the various options which your Teapot uses. Different set of machine learning algorithms which it uses. Okay, and it will also store the model predictions, right, as a new feature. And then these are the feature pre-processing steps which it is going to experiment. And then here you have feature selection operations which it is going to experiment with. All right. I think, yeah. Okay. A few more things and then we'll jump in. So friends, Teapot has a default option of trying out 100 different pipelines or 100 different machine learning algorithms. And in each of that algorithm, it will experiment with a lot of hyperparameters. These are the default options. And even if these are the default options, then 100 into 100, which is 10,000. 10,000 different pipelines is what Teapot is going to build by default. And hence, it is going to be time consuming. If it is time consuming, you might encounter an error which says the Teapot optimizer did not converge because maybe the amount of time, maybe you told, you supply to the model that you want the model to run for 15 minutes. It will run for 15 minutes and then it will stop. It might not try out all the options within 15 minutes. And also, it might give you, Teapot might give you multiple optimal pipelines which are optimized. Out of all of that, you need to choose the best pipeline. And Teapot can be used to handle regression, classification, parallel processing, neural networks, all of these tasks. Teapot can handle a bunch of these tasks. Okay. Next, we have feature tools. But before we get into feature tools, we need to get into the practicals. So I would be resorting to Google Colab. We'll write Python code in Google Colab. It'll be easy, right? There won't be any headache of installing softwares on your computer. So let me click on this. And within Google Colab, you have, I think, 3 options. One is a free option. Okay, you have one option, which is a free option, wherein you can use the free resources. You have another option, which is Google Colab Pro. Okay, so it's not taking me there, but then you can go to the option and then you can just figure out and then make the payment. Here we go. You have Collab Pro. Okay, and you also have Collab Pro Plus. I have Collab Pro, but you need not go for it, friends. You can use the free version as is. When you open Google Colab for the first time, this is how it appears. Let me open it. Just to show you on how Google Colab appears. Still loading, not sure why. This is how it appears, right? I'll show you a few options here. If you just go here in this cell, if you say 1 plus 1, and if you click on run, you see here it says connect, right? When I click on run, it will start allocating a computer for you on the cloud. Google will start giving you a free computer to process. I click on this. Look at this, it's saying connecting. It is saying initializing. That is, your Python engine is getting initialized. And 12 GB RAM and 225 GB hard disk is allocated for you. I just forward my mouse on that and it says Python 3 Google Compute Engine is a backend, etc. Right? And another option is go to runtime, click on change runtime type. And here you will find 2 different options, GPU and TPU. GPU is something which probably I would recommend you guys to consider. TPU is when you use TensorFlow library, that is when I recommend you to use that. So I'll select GPU and save it. If you want to run the next line, the moment you clicked on save, it is assigning you the GPU computer. Now, when you hover your mouse on this and click on that, you'll get 2 options, code, text. You also have it here, code, text. Wherever you want to add, you can just click on code and you can give the other options. Let me say 8 multiplied by 3. And if I click on run here, it will quickly give the answer. All right. Another option that I want to show you is click on this folder icon. The moment you click on that, here you will see an option called Google Drive. So you click on this, later click on this. This is your drive. When you click on that, it is going to mount the Google Drive. It's mounting the Google Drive. Now you can say connect to your Google Drive will start appearing here. Whatever files you have on your Google Drive can be accessed. Whatever files you have here, you can access them here. Okay. But yeah, it's taking a while. It's still mounting the Google Drive. Let it mount the Google Drive, and then yeah, it has done that. So here is my drive. When you go to my drive, you'll have all the folders and files pertaining to Google Drive. Pertaining to your Google Drive. You can create a different folder. If this is a file that you want to access, you can access. If this is the file you want to access, you can. Right. So if you want to access any of these files, just right click, say copy path. Not right click, just click on the 3 dotted lines and say copy path. That's how things work. Okay. The reason why I'm showing you this is because we will be making use of Google Collab to execute a few of the algorithms, right? So that's why I recommend you guys to understand these basic things. You also have text to be added. Say you're uploading data, uploading the data set. Okay. Using Python. In that way, you can put comments and then move on. So if, the moment you have comments, it will become easier and your code will be more readable. Friends, when you attend interviews, 2 things happen. One is in the first round of interview, usually people ask you about yourself. They'll say, tell me about yourself. They would ask you theoretical questions on your projects that you worked upon, etc. And most often than not, as part of the second round of interview, they will give you a data set and business problem. And they will give you 24 hours or so time, and they'll ask you to solve it. Okay, and when you solve it, that means you need to write your code and give it to the interviewer. They are going to look at whether you have written the code in line with the best practice, and do you have comments beside each line of code, or for each line of code, do you have a comment on what that particular line does? Okay, so these are very, very important things. All right, so I'll stop here, and tomorrow it will just be hands-on. We have Teapot. I'm going to explain you each and everything on what Teapot does and how you can make use of Teapot and get the best code out. Thank you so much until then, and enjoy this learning. Thank you all, friends. Bye.